have you ever just stopped and thought about the absolute magic that's happening inside your phone, or your smart TV, or even the servers that are beaming this to you right now? Well, there's an invisible engine, a kind of master conductor, that's making it all possible. And today, we're going to pull back that curtain.
So, what do you think it is? What's the most important program you use? Your web browser? Maybe your favorite social media app? Well, the answer is probably going to surprise you. It's not something you ever click on or launch yourself. The most critical program on your device is the absolute core of the operating system, a thing called the kernel.
Okay, so let's get right into it. The best way to think of the kernel is as the computer's hidden boss. It's the CEO, the brain of the operation, maybe even the conductor of a massive digital orchestra. It's the one central piece of code that manages every single thing your device does, from the CPU to the memory to the screen. At its heart, the kernel is really the ultimate translator. It's the critical bridge that lets your software, like a word processor, actually talk to your physical hardware, like your keyboard or your hard drive. Without the kernel, your apps would be clueless. They'd have no way of knowing how to save a file or send something to the printer.
You see, the kernel is a master juggler, a resource manager. It decides which app gets to use the processor and for how long. It carves up the memory, and crucially, it makes sure that if one of your apps crashes, it doesn't take the whole system down with it. It's all about creating a stable, fair, and protected place for all the other programs to do their thing.
So this world-changing program, the Linux kernel, where did it even come from? You might think it was created in some huge, multi-billion-dollar corporate lab. But nope, believe it or not, it all started as one person's hobby project. Let's go back to 1991. A 21-year-old student in Finland named Linus Torvalds wanted a free Unix-style operating system for his own computer. So what did he do? He just started building one. And then he did something that changed everything. He posted his early work online and asked if anyone wanted to help out. And what happened next was, well, incredible. Developers from all over the world jumped in, turning this one little project into a global phenomenon. Now, when you're building a kernel, you face a huge choice right at the beginning. It's almost a philosophical battle about how to structure the whole thing. And the path you choose has massive consequences for performance, stability, and just how complicated it all becomes.
And this brings us to a huge trade-off. Linux chose what's called a monolithic design. This means all the core services are packed into one big, fast, protected space. The goal? Raw speed. The alternative is a microkernel, which breaks things up into smaller, separate services. That makes it more resilient. If one part fails, the whole system doesn't necessarily crash. But Linux made a bet on performance, and that all-in-one design choice is exactly why it's so dominant in places like supercomputing, where speed is king.
So what about kernels that claim to be a mix of both styles? A hybrid kernel? Well, Linus Torvalds doesn't really mince words. He pretty much calls the whole hybrid label pure marketing. He's famously direct, and this quote really just captures the no-nonsense, decisive thinking that went into Linux's design.
Okay, so to keep the whole system stable, the kernel has to protect itself from all the other programs running. And it does this by creating a really strict boundary, a great divide, right in your computer's memory.
Here's a great way to think about it. Imagine a huge concert. All of your apps, they're out in the general admission crowd. We call that user space. But the kernel is backstage with an all-access pass. That's kernel space. And separating them is a very, very firm security line, which is actually enforced by the computer's hardware. This whole setup stops a buggy app from just wandering backstage and messing with all the important controls.
So how does an app out there in the crowd ask the protected kernel for help? It uses a special official process called a system call. It's kind of like presenting a ticket at a security checkpoint. The app makes a formal request, the CPU then flips a switch into a special privileged kernel mode, the kernel does the task safely, and then it switches the CPU right back. This little dance happens thousands of times a second every time you do basically anything like saving a file or connecting to Wi-Fi.
All right, all this technical detail is really cool, but what's the real-world result of all this? Well, it's pretty simple. The Linux kernel, thanks to its design and its open-source development, quietly rules the entire world of computing.
And this right here is the secret sauce. Linux isn't built by just one company. It's a massive collaborative effort. We're talking thousands of developers, many from companies that are normally fierce rivals: Google, IBM, Intel, you name it. They're all working together, all contributing to this one shared foundational piece of code. It's a truly unique way to build software.
So, where do you actually find Linux? The short answer is everywhere.
The cloud that you use every day, the websites you visit, they run on Linux. All 500 of the world's fastest supercomputers, they run Linux. And yeah, that Android phone in your pocket, its operating system is built on top of the Linux kernel. It really is the invisible backbone of almost all modern technology.
So why did it succeed so spectacularly? Well, it really comes down to three key things. First, it's open source. It's free for anyone to use and change. Second, it's modular, so you can add or remove drivers and features easily. And third, it's incredibly portable. It can be made to run on almost any kind of hardware you can imagine, from a tiny little router to a gigantic supercomputer.
But don't make the mistake of thinking the kernel is just a finished piece of history. It's a living, breathing project. It is constantly evolving to tackle the newest challenges in computing.
And a perfect example of this is a technology called eBPF. This is a real game changer. It basically lets developers run tiny, safe programs directly inside the kernel, but without having to change the kernel's main code. This unlocks incredible new abilities for advanced networking, security monitoring, and all sorts of other things. It's absolute proof that this 30-year-old project is still on the cutting edge.
So, at the end of the day, the Linux kernel is this amazing story of how a collaborative, open-source project that started as a hobby could become the foundation of our entire digital world. It kind of makes you wonder, doesn't it? What's the next great software revolution going to look like, and will it be built on those same principles of openness and global collaboration?